You are standing on a beach in the Marquesas Islands, and it is roughly the year 1000. Behind you, the volcanic cliffs rise so sharp and so green they look like they were drawn by someone who had never seen a real mountain and was just guessing. In front of you, there is nothing. Not nothing like an empty parking lot. Nothing like the edge of a map. Water in every direction, all the way to where the sky closes the lid on it. Somewhere out there, more than 2,000 miles away, is a chain of islands nobody in your family has ever seen. Nobody has a name for it yet. There is no legend about it, because legends need someone to come back and tell them. You are about to get into a canoe, not a canoe like the word makes you picture either. This is two hulls lashed together with rope made from coconut fiber, carrying a crew of maybe 30, along with pigs, dogs, chickens, and enough taro and breadfruit shoots to start an entire agricultural system from scratch, because whatever you find out there, if you find anything, is going to need to be planted. You have no compass. You will not for another 600 years, and even then it will belong to someone else's ships. You have no metal instruments of any kind. What you have is a memory palace built out of stars, a working knowledge of how ocean swells bend around land you cannot see, an ear for the way birds behave at different distances from shore, and elders who have drilled all of this into you since before you could swim. And you are going to sail into open water, off the edge of everything anyone in your world has ever charted on purpose. Here's the part that should stop you for a second. For most of the 20th century, the people who wrote the history books did not believe this happened on purpose. They believed the Pacific Islands were settled by accident, fishermen blown off course, canoes caught in storms, drifting for weeks, occasionally washing up somewhere with survivors, a whole ocean populated, in this telling, by a few thousand years of shipwrecks that got lucky. It is one of the strangest cases of a civilization looking at somebody else's achievement and simply refusing to believe it was intentional, because what actually happened is almost the opposite of an accident. It might be the most intentional feat of exploration in human history before the 20th century, and it was done without writing anything down. This is the story of how a few hundred generations of Pacific Islanders turned the largest ocean on the planet into a network of roads, using nothing but boats they built by hand and a navigation system they carried entirely in their heads. It's a story about genius that got mistaken for luck, about a mystery gap of 1,000 years that still doesn't have a clean answer, about an island so remote that reaching it might be the single greatest maritime accomplishment of the ancient world, and about how the whole system very nearly died out completely before one man from a tiny atoll saved it just in time. Get comfortable. We're going to need the whole ocean for this one. A quick word before we start: if you're the kind of person who likes their history with the boring bits trimmed off and the interesting bits kept in, go ahead and hit subscribe now, because that's basically the whole channel. No rush on it. It'll be here when you're doing the dishes later too. Alright, let's go back to where this whole thing starts, which is not the Pacific Islands at all. It's a place you'd never guess. Where they came from around 5,000 years ago, on the island of Taiwan, a group of farmers were dealing with a problem that a lot of farmers deal with. There wasn't enough land. Taiwan sits just off the coast of mainland China, and by roughly 3000 BCE it was home to people speaking a family of languages linguists now call Austronesian. These were rice and millet farmers, but they were also, crucially, boat people. Not boat people in the sense of living on boats. Boat people in the sense that the ocean wasn't a wall to them. It was a hallway. Here is the detail that tends to surprise people. Every language spoken across the entire Pacific Islands today, from Hawaii to New Zealand to Easter Island, a triangle of ocean covering 10 million square miles, traces back to this one island. Not a continent, not an empire, an island roughly the size of Maryland. You can actually watch the migration happen, language by language, like watching a photo slowly develop. The linguists did this work by comparing vocabulary and grammar across hundreds of Pacific languages, sorting them into a family tree, and the tree points backward in time to Taiwan with almost embarrassing precision. It's one of the cleanest examples in the world of a whole population's history preserved entirely in the words they used for canoe, for wind, for the number 4. So here's what happened. Somewhere around 3000 BCE, groups of these Austronesian speakers started moving south, first into the Philippines, then down through what's now Indonesia. And by around 1500 BCE, a very particular version of this culture starts showing up in the archaeological record, and it has a name that sounds like a brand of pottery you'd find at a farmer's market. It's called Lapita. Lapita culture is named after a site in New Caledonia where archaeologists found broken pottery with an extremely distinctive design, geometric patterns pressed into the wet clay with a toothed stamp before firing. It looks almost like something out of a modern textile pattern book. Dentate stamping, it's called, because the stamp looks like a row of teeth. And here's the thing about Lapita pottery. Once archaeologists learned to recognize it, they started finding it everywhere. Papua New Guinea, the Solomon Islands, Vanuatu, Fiji, Tonga, Samoa. Same style, same techniques spread across thousands of miles of ocean, appearing in the ground at sites that are, in some cases, separated by more open water than existed anywhere else humans had crossed at that point in history, which means the pottery is basically a trail of breadcrumbs. Except the breadcrumbs are broken ceramic fragments, and the person who dropped them sailed roughly 4,000 miles of open Pacific water to do it, over the course of a few centuries, using boats built from trees and rope made from plant fiber. Think about the timeline here for a second, because it puts things in perspective. The Lapita expansion into the deep Pacific happens around 1000 to 900 BCE. That's roughly the same era as King Solomon in the Bible, the founding of Carthage, and the early Iron Age in Greece. While people in the Mediterranean were hugging coastlines and occasionally working up the nerve to cross open water between islands they could practically see from shore, people in the Pacific were sailing for weeks at a time into water where the nearest land, if there was any land at all, might be 500 miles away in a direction nobody had confirmed. Nobody built a stone monument to this. There's no Lapita equivalent of the pyramids. What they left behind is broken pottery, some post holes, shell tools, pig bones, and an extraordinary amount of linguistic evidence buried in languages that are still spoken today. It's easy to miss how enormous this achievement is precisely because it didn't leave behind anything that looks impressive in a museum case. A shard of pottery doesn't communicate. This culture solved deep ocean navigation 500 years before anyone else on Earth, the way a 200-foot stone monument does, but it should. Now, why did they leave Taiwan in the first place? This is where it gets a little more human and a little less like a straight line on a map. Some of it was almost certainly population pressure. Islands only hold so many people, and Austronesian populations were growing. Some of it was probably resource competition, the same reason every migration in human history has ever happened. But there's another piece of this that's worth sitting with, which is that these were people who had, at some point, developed a relationship with the ocean that treated distance differently than most cultures did. If you grew up on a small island, the ocean isn't scary in the abstract way it might be to someone who grew up inland. It's just the space between places. You learn its moods the way you'd learn the moods of a river, or a road, or a difficult relative. It gives and it takes, and mostly it's just there doing its thing, and your job is to understand it well enough that it stops being an obstacle and starts being a route. That relationship with water is the actual technology here, not the canoe, not the star charts. Those come later in the story, and we'll get to them. The real technology, the one that made everything else possible, was a culture that looked at open ocean and asked, what's on the other side of that, instead of how do we avoid that? It's worth pausing on how differently other ancient seafaring cultures approached this same problem. The Phoenicians, often celebrated as the great sailors of the ancient Mediterranean, mostly hugged coastlines. So did the early Greeks. Open water sailing out of sight of land, for days or weeks at a stretch, with no landmark to correct your course, was something most of the ancient world avoided if it possibly could. It wasn't stupidity. It was reasonable risk management. Losing sight of land meant losing your only reliable way of knowing where you were. The people who became the ancestors of every Pacific Islander alive today didn't have that option, and instead of treating it as a limitation, they built an entire body of knowledge around solving it. And they did this while also carrying in the holds of their canoes essentially the entire starter kit for a portable civilization. Not just people, pigs, dogs, chickens, taro, breadfruit, yams, bananas, coconut. The idea wasn't just, let's go see what's out there. The idea was, let's go see what's out there, and if we find it, let's be ready to live there immediately. That detail matters more than it might seem to at first. This wasn't exploration in the sense of a small scouting party going out to look around and report back. This was colonization voyaging, built for one-way trips where turning back wasn't really the plan. You don't load a canoe with breeding pairs of pigs if you're just going to look around for a week and come home. By around 1200 BCE, Lapita settlements had reached the Bismarck archipelago near Papua New Guinea. By 1000 BCE, they'd pushed out through the Solomon Islands, Vanuatu, and New Caledonia. And then, in a burst that still gets archaeologists a little worked up when they talk about it, Lapita voyagers crossed the open water into Fiji, then Tonga, then Samoa, by around 900 BCE. That last stretch from Vanuatu out to Fiji and beyond involves open ocean gaps of several hundred miles with nothing in between. No stepping stone islands, no safety net, just water and the confidence that there was something worth finding on the other side of it. They were right. There was. And once they got to Tonga and Samoa, something strange happened. They stopped. The machine they built before we get to the pause, and we will get to the pause, because it's one of the strangest parts of this whole story. We need to talk about the boats. Because none of this works without them, and the boats themselves are a story about problem solving under constraints that most engineers today would find genuinely humbling. Picture the tools available to a Pacific Islander boat builder around 1000 BCE, or honestly, right up through the 1700s, since the technology barely changed for thousands of years because it didn't need to. No metal, no nails, no screws, no bolts, no saws in the sense you're picturing. Stone adzes for cutting and shaping wood, shell tools for finer work, fire sometimes to help hollow out a log. Coconut fiber, twisted and braided into cordage, for holding the entire vessel together. That's it. That's the whole toolkit. And out of that toolkit came the double-hulled voyaging canoe, a design so effective that when European explorers finally encountered it in the 1700s, several of them wrote home describing it as faster and more seaworthy than their own ships. Captain James Cook, who was not a man inclined to hand out compliments to people he considered primitive by the standards of his era, wrote after observing Tongan and Fijian sailing canoes that they sailed rings around his own vessels. He clocked some of them moving at speeds his own square-rigged ships couldn't match, in conditions his own ships handled poorly. That's not a small thing for a British naval officer in the 1770s to admit in his journal. So how do you build something like that with stone tools? You start with 2 hulls instead of 1. This is the part that trips people up if they're picturing a canoe the way the word usually gets used today, some narrow little thing you paddle around a lake. A Pacific voyaging canoe is 2 full hulls, each one a hollowed and shaped log or a series of hollowed planks lashed together, running parallel to each other, connected by a rigid platform lashed across the top. That platform is where the crew lives. It's where the food is stored, where the fire pit sits for cooking, sometimes where a small shelter is built for sleeping. The double-hull design does something clever that a single hull can't. It gives you stability without needing a heavy keel weighing the boat down, and it gives you enormous cargo capacity relative to the boat's size and weight. Some of the larger voyaging canoes, the kind used for long ocean crossings and full colonization voyages, could stretch over 100 feet long and carry crews and cargo numbering in the dozens, along with livestock and enough food and water for weeks at sea. Building the hull itself was its own extraordinary process. In places with large trees, like the koa forests of Hawaii or certain tree species in the Society Islands, a single massive log could be selected, felled, and slowly hollowed out using fire and stone adzes, a process that could take months. In places without trees large enough for a single log hull, like many of the smaller atolls, builders developed plank construction instead, shaping individual planks and sewing them together edge to edge with cordage, then caulking the seams with a mixture of plant materials and gum to keep the water out. No nails. Every plank held to the next one by rope, pulled tight enough, and lashed with a pattern precise enough that the whole hull could flex slightly with the ocean's swell instead of cracking under the strain. That flex matters more than it sounds like it should. A rigid hull in heavy seas is a hull under constant stress at every joint, fighting the water instead of moving with it. A lashed hull, built from wood and rope instead of wood and nails, has a small amount of give built into every connection point. It groans and creaks and shifts a little in big waves, and that shifting is exactly what keeps it from snapping apart. Modern boat builders call this kind of flexibility working in a hull, and they still argue about how much of it is a feature versus a bug. Pacific Islander shipwrights had already answered that question 3,000 years earlier, using nothing but experience and the wreckage of boats that got it wrong. Then there's the sail. Early Pacific sails were made from woven pandanus leaf, that spiky-looking plant you've probably seen in tropical landscaping without knowing what it was. Its fibers stripped, dried, and plated into mats, then sewn together into a sail shape. The classic design used across much of the Pacific is called a crab claw sail, two long spars crossing near their base and spreading apart toward the top, giving the sail a shape that does genuinely look like a claw when it's rigged and full of wind. The crab claw sail is not a simple piece of technology, whatever it might look like from a distance. It's remarkably efficient for sailing close to the wind, meaning it lets a canoe make progress even when the wind isn't blowing conveniently from behind, which matters enormously when you're trying to navigate toward a specific target thousands of miles away, and the wind has its own opinions about where you should go. Sailing directly downwind sounds appealing until you remember that it also means you can't turn around and sail home the same way if you need to. A sail that can work at an angle to the wind, tacking back and forth, gives a voyaging canoe options that a simple downwind rig doesn't. And connecting the two hulls, running the sail, holding the whole structure together under load, in salt water, in tropical heat that degrades plant fiber faster than you'd like, was cordage made almost entirely from coconut husk fiber called senet. Making senet rope was its own specialized craft, one that took years to master, and a single large voyaging canoe could require literally miles of it, braided by hand, strand by strand, in patterns specific to different parts of the vessel. Some lashing patterns were purely functional, others carried decorative and even spiritual significance, the kind of detail that tells you this wasn't just engineering to these people. It was closer to something sacred. Here's a number that tends to land hard with people who haven't thought much about ancient boat building before. A large voyaging canoe, fully rigged, could take a specialized team of builders, under the direction of a master canoe builder whose knowledge had been passed down for generations, somewhere between 1 and 2 years to complete. And building it wrong, even in a small way, wasn't a problem you'd discover at the dock. You'd discover it 200 miles offshore, in open water in the dark, with no way to call for help and no way to turn around fast enough to matter. So every part of the process, from selecting the right tree to shaping the hull, to lashing the cordage, to weaving the sail, carried the full weight of that reality. This had to work, not probably work, because the ocean does not offer partial credit. There's a quieter detail buried in all of this that's easy to walk past too fast. These voyaging canoes, the big ones built for open ocean colonization, weren't one person or even one family projects. They were community projects, requiring specialists in wood selection, in adze work, in sennet braiding, in sail weaving, in ritual and ceremony around the process, because launching a canoe wasn't treated as a purely mechanical event. It was treated as something closer to sending a piece of the community itself out into the unknown, carrying with it the survival of everyone aboard, and if the voyage succeeded, the survival of a whole new settlement built from nothing but what fit in the hulls. You built the boat because you were about to trust your entire life and the lives of everyone you loved on board to weather that boat held together in the middle of the largest ocean on the planet. They got it right often enough that we're all here talking about it. Not every time. We'll get to that too. But often enough that an entire ocean got settled, island by island, using boats built with stone tools and rope made from coconuts. Now, the other half of the equation. Because a boat that can survive the ocean doesn't mean much if you don't know where you're going. And this next part is where the whole story tips from impressive into something that still, honestly, borders on unbelievable. The compass in their HEADS, here's a question worth sitting with for a second before we answer it. If you took away someone's phone, their compass, their GPS, any instrument at all, and put them in a boat in the middle of the ocean with no land in sight, how long do you think it would take before they had absolutely no idea which direction they were facing? For most of us, the honest answer is minutes, maybe less. Now here's the part that should genuinely mess with your sense of what the human brain is capable of. There were navigators in the Pacific who could sail for 3 weeks across 2,000 miles of open water, out of sight of land the entire time, and land within a few miles of a specific target island. Not a general region, a specific island, sometimes less than 10 miles across, sitting alone in an ocean that covers a third of the planet. They did this with no instruments. None, not a compass, not a sextant, not a chart. The entire navigation system lived inside one person's head, built from decades of training, and it is, without exaggeration, one of the most sophisticated wayfinding systems any human culture has ever developed. Let's take it apart piece by piece, because each piece on its own is impressive, and stacked together they become something that still makes modern navigators a little uneasy about how much we've outsourced to machines. The stars. This is the part people usually know a little about already, so let's go past the surface of it. A Pacific navigator didn't just glance up and use the stars the way you might use the North Star to figure out roughly which way is north. They used something closer to a rotating three-dimensional map that lived in memory, called, in the Hawaiian tradition, the star compass. Here's how it worked. The horizon was mentally divided into a set of points, similar in concept to the way we divide a compass into degrees, except built entirely around where specific stars rise and set. A given star always rises at the same point on the horizon and sets at the same point on the horizon, night after night, year after year, because the Earth's rotation is reliable in a way that almost nothing else in a navigator's world was. So a trained navigator memorized, for potentially hundreds of stars, exactly where on the horizon each one rose and set. That gave them fixed points. But here's where it gets genuinely elegant. No single star stays usefully positioned in the sky all night. It rises, climbs, and eventually gets too high overhead to give you a reliable bearing, or it sets. So a navigator memorized entire chains of stars, one handing off to the next, each one rising at roughly the same point on the horizon as the last one, so that across a full night they had a continuous, overlapping sequence of stars to steer by. This is sometimes called a star path. Think about the sheer memorization involved. Hundreds of stars, their rising and setting points. Which ones handed off to which others, at what point in the night, at what time of year, because the visible stars shift with the seasons too. This wasn't a system you could read off a page because there was no page. It lived entirely in the navigator's memory, drilled in from childhood, tested constantly, refined over an entire lifetime of actual voyages. And on a cloudy night with no stars visible at all, the system had to keep working anyway, which is where the next piece comes in: the swells. This might be the single most impressive piece of the whole puzzle, and it's the part that takes the longest to train, because it's the part that's hardest to explain in words, even to another navigator. It has to be felt. Ocean swells are different from ordinary wind-driven waves on the surface. Swells are deep, long, rolling patterns of energy moving through the water, generated by distant weather systems and winds, sometimes thousands of miles away, and they travel in remarkably consistent directions for extremely long distances, often for days or weeks, holding their pattern even as local surface conditions change completely on top of them. A skilled navigator could feel the difference between multiple swell patterns crossing each other beneath the canoe, distinguishing a primary swell from a secondary, even a tertiary one, essentially reading 3 or 4 different wave systems simultaneously through the movement of the hull beneath their body. Some navigators trained by lying down inside the canoe, in the dark, feeling the pitch and roll and yaw of the vessel with their whole body instead of watching the water with their eyes, because the body, it turns out, can sense subtleties that the eye tends to miss or get confused by, especially at night, especially when you're exhausted, which 3 weeks into an open ocean crossing you very much are. Swells also do something else useful, something that becomes critical the closer you get to land. They bend. When a swell pattern encounters an island, it refracts around it, similar to how light bends passing through water, creating a distinctive pattern of interference where waves wrap around both sides of the land and cross each other again on the far side. A trained navigator could detect this refraction pattern from many miles away, sometimes as far as 30 or 40 miles out, well before any island was visible on the horizon, which meant a canoe could pick up on land it couldn't yet see, simply by noticing that the water was moving in a way that only made sense if there was something solid interrupting the swell somewhere nearby. The birds. Certain seabirds, particularly species like the white tern and certain boobies, roost on land at night but fly out to fish during the day, often traveling 20 or 30 miles from shore before returning each evening. A navigator who spotted these birds and who knew their specific flight patterns and behaviors well enough to distinguish, flying out in the morning from heading home at dusk, could use that information to estimate both the direction and rough distance to land that still wasn't visible. The clouds, islands, especially ones with any elevation at all, disrupt airflow and heat differently than open ocean does, which frequently produces distinctive stationary cloud formations hovering directly above or just downwind of the land. Lagoons on low coral atolls reflect a pale greenish light up onto the underside of clouds above them, a phenomenon experienced navigators learned to recognize from a significant distance, essentially reading the color of the sky as a clue about the color of the water it was reflecting. Phosphorescence. In certain conditions, bioluminescent streaks in the water, caused by disturbed marine organisms, were reported by some traditional navigators as showing patterns connected to nearby land, though this is one of the more debated and least fully understood pieces of the traditional knowledge, partly because it's difficult to study, and partly because much of this specific detail was lost before it could be recorded. Put all of this together: stars, swells, birds, clouds, wind, water color, water temperature, even the particular way the canoe felt different in the water depending on ocean depth and current, and you get a navigation system that didn't rely on any single input, because any single input could fail you on a given night. It relied on a navigator's ability to constantly cross-reference dozens of overlapping signals, updating a mental model of the canoe's position continuously, hour after hour, for weeks at a time, without ever writing a single number down. There's a concept from the Caroline Islands, a chain of atolls in Micronesia, where some of this navigational tradition survived furthest into the modern era, called etak. It's genuinely one of the more mind-bending ideas in the whole history of navigation, and it's worth slowing down for. In a Western navigation mindset, you generally think of yourself as moving and the islands as staying still. You track your own position changing relative to fixed points on a map. etak flips that entirely. In the etak system, the canoe is conceptually treated as stationary, sitting still in the middle of the ocean, while the islands around it are the ones moving, sliding past reference points in the sky. A navigator would track a specific reference island, one not necessarily visible and sometimes not even the destination, and mentally track how far that island had conceptually moved relative to the position of specific stars on the horizon, as a way of tracking how far the canoe had actually traveled. It sounds almost backward when you first hear it described, but it's not actually about physics. It's about cognition, about building a mental framework that makes an otherwise impossible tracking problem, keeping continuous count of your position across 3 weeks of featureless ocean with 0 fixed visual references, into something a human mind can actually hold on to and reason about. etak turns distance and progress into something the navigator could feel and estimate continuously, breaking a 2,000-mile voyage down into a sequence of conceptual segments, rather than one incomprehensible, undifferentiated stretch of blue. This is worth pausing on, because it's easy to read a description like that and file it under clever trick and move on. It's more than that. It's a completely different cognitive model for solving the exact same problem modern navigation solves with satellites and math, and it worked well enough for long enough to settle an entire ocean. None of this was written down. There's the detail that should really land. No charts, no logbooks, no manuals. Every piece of this entire system, hundreds of stars and their rising points, swell patterns and how to distinguish them, bird behaviors, cloud reading, the ETAC framework itself, lived and died with individual master navigators who trained their successors over years, sometimes decades, through direct instruction, memorized chants, physical demonstration, and an enormous number of actual practice voyages where getting it wrong had genuinely fatal consequences. Training a master navigator in the traditions where we have decent records of the process could take upward of 20 years, not 20 years of casual study. 20 years of intensive, structured, high-stakes apprenticeship, memorizing star compasses, learning to read swells with your whole body, going out on real voyages under the supervision of an already trained master, slowly accumulating the kind of pattern recognition that can't be rushed, because it depends on having personally experienced hundreds of different combinations of sky and sea, and having built an intuition for what they mean together. If that training chain broke, even once, even for a single generation, the knowledge didn't get passed down in a book you could later dig up and reconstruct from. It was just gone, which is exactly what very nearly happened, and we'll get to that story, because it's one of the more dramatic near misses in this entire history. But first, we need to go back to the beginning of the voyaging itself, because there's a genuine mystery sitting right in the middle of this timeline that historians and archaeologists still argue about. The first leap lets go back to Tonga and Samoa, around 900 BCE, where we left the Lapita voyagers a couple chapters ago, standing on new beaches with pottery in their hands and pigs coming down the gangplank behind them. Tonga and Samoa are geographically the western edge of what we now call Polynesia. Everything east of this point, Hawaii, Tahiti, the Marquesas, Easter Island, New Zealand, the entire enormous triangle of islands that most people picture when they hear the word Polynesia, was settled by people descended from these first arrivals in Tonga and Samoa, or by their close relatives. So this moment, roughly 3,000 years ago, on a handful of islands most people couldn't find on a map today, is genuinely one of the foundational moments in Pacific history. This is where Polynesian as a distinct cultural identity essentially starts taking shape, evolving out of the broader Lapita culture that had been expanding across the Pacific for the previous several centuries. You settle into a new place like this the way any group of farmers with livestock would. You clear land. You plant your taro and your breadfruit and your yams, crops you brought specifically because you knew, or at least suspected, that wherever you ended up wasn't going to already have them growing. You build permanent settlements, not the temporary kind. You start making pottery locally instead of carrying it from the last stop, which is actually how archaeologists can track this whole migration in the first place, because pottery styles shift and localize the longer a group stays in one place, developing their own regional quirks, the way accents drift apart between separated populations of the same language. And that's exactly what happened in Tonga and Samoa. Over the following centuries, the distinctive Lapita pottery style that had marked the migration all the way from the Bismarck archipelago started to change, and eventually it disappeared from the archaeological record almost entirely. Later Polynesian cultures largely abandoned pottery altogether, for reasons that are still debated, possibly connected to the local clay simply not being ideal for it, possibly connected to a cultural shift toward other kinds of containers, like carved wood and woven baskets, that did the job just as well without requiring a kiln. Losing the pottery tradition is actually a small preview of a theme that runs through this whole story. Polynesian cultures were not preserving traditions out of sentiment. They kept what worked and let go of what didn't, generation after generation, refining an entire toolkit of survival technology down to exactly what a small, resource-limited island community actually needed. Pottery, it turns out, wasn't one of those things. Navigation absolutely was. Within Tonga and Samoa, over the following centuries, something else important developed too: increasingly sophisticated maritime societies, with complex chiefdoms, extensive inter-island trade networks, and crucially growing seafaring expertise built specifically around this new island environment, which was different in important ways from the environments their Lapita ancestors had come from further west. The islands out here were smaller, more scattered, further apart. Successfully living in this part of the Pacific required getting even better at exactly the kind of long-distance, open-water voyaging that had brought people here in the first place. And for several centuries, that's exactly what happened. Tonga in particular developed into a genuine regional maritime power, sometimes described by later archaeologists as a maritime chiefdom whose influence, through trade and voyaging networks, extended out across a significant portion of the Western Pacific. Then, and this is the part that turns into one of the real puzzles of this whole story, the pace of expansion slowed down, way down, for somewhere between 500 and 1,000 years, depending on which set of archaeological dates you trust most. And there's real disagreement here. The eastward push of Polynesian settlement essentially stalls out. Tonga and Samoa remain the eastern frontier of the Pacific for an enormous stretch of time, while the vast remainder of the Polynesian Triangle, the Marquesas, the Society Islands, Hawaii, Rapa Nui, New Zealand, sits completely unsettled by humans for centuries after people first reached Fiji, Tonga, and Samoa. Why would a culture that had just proven it could cross hundreds of miles of open ocean on purpose, using boats and a navigation system sophisticated enough to do it reliably, suddenly just stop? That's the question the next chapter is built around, and it's one of the genuinely unresolved mysteries in this entire history. There isn't a clean, agreed-upon answer. But there are some very good theories, and walking through them tells you almost as much about how this whole society actually worked as knowing the answer for certain would. The long pause lets be honest about something up front. Nobody knows for certain why this pause happened. Anyone who tells you they have the definitive answer is skipping past a lot of genuine scholarly disagreement to get there. What we have instead is a handful of serious theories, each backed by real evidence, none of them able to fully explain the gap on its own. So let's walk through them the way the archaeologists actually argue about them, because the uncertainty itself tells you something true about how hard this history is to pin down. Theory 1. The winds were against them. This is one of the more physically grounded explanations, and it has to do with a climate pattern most people have heard of without necessarily connecting it to ancient migration. The El Niño Southern Oscillation, the same system that shapes weather patterns across the Pacific today. Under normal conditions, trade winds across the central Pacific blow predominantly from east to west, which means that sailing east, from Samoa and Tonga toward the Marquesas and the rest of the eastern Pacific, means sailing against the prevailing wind almost the entire way. That's not an impossible task for a culture with sails capable of tacking at an angle to the wind, as we talked about with the crab claw sail, but it is a significantly harder and slower undertaking than sailing with the wind at your back. Some researchers have proposed that during certain climate phases, extended periods of unusually frequent El Niño conditions may have temporarily reversed or weakened these prevailing easterly trade winds, creating windows of time when sailing eastward into the remainder of the Pacific was considerably more favorable than usual. Under this theory, the eastward expansion wasn't a matter of Polynesian navigators simply deciding, after centuries, to try harder. It was a matter of waiting, whether consciously or not, for climate conditions that made a fundamentally difficult voyage meaningfully easier. It's a genuinely elegant theory because it doesn't require assuming anything changed about the navigators themselves. Same skill, same technology, same ambition, just different wind. Theory 2, they didn't stop, we just haven't found the evidence. This is less a competing theory and more a serious caution from some archaeologists that the pause might be at least partly an illusion created by gaps in the archaeological record itself, rather than a real gap in human activity. Organic materials degrade fast in tropical environments. Wood rots. Plant fiber decomposes. Without pottery, which as we covered had largely fallen out of use by this point, the physical evidence a voyaging culture leaves behind gets a lot thinner and a lot harder to find and date precisely. Some researchers argue that ongoing exploratory voyages may well have continued during this period, without necessarily resulting in permanent, large-scale settlements that would leave a clear, datable archaeological footprint behind for us to dig up 3,000 years later. Under this view, the pause isn't a pause in voyaging at all. It's a pause in successful, large-scale colonization, which is a meaningfully different thing, and one that's much easier to imagine happening gradually and unevenly rather than as one clean, society-wide decision. Theory 3. It simply took a long time to build a big enough society. There's also a straightforwardly demographic and logistical explanation sitting underneath all of this. Successfully colonizing genuinely remote islands, ones with no nearby neighbors, no easy resupply, no fallback plan, requires more than just the technical ability to sail there. It requires a large enough source population back home to sustain repeated voyaging attempts. It requires accumulated experience with the kind of truly long-range, open ocean navigation that the more central Pacific hadn't fully demanded yet. It requires enough surplus resources, enough spare canoes, enough spare people to absorb voyages that failed, and some certainly did fail, without it crippling the home community. Tonga and Samoa may simply have needed those first several centuries to build up the population, the accumulated maritime knowledge, and the sheer societal capacity required to reliably launch voyages capable of reaching islands 1,000, 2,000, in some cases nearly 2,500 miles further east, across stretches of open ocean considerably longer and more dangerous than anything the earlier Lapita voyagers had faced getting to Fiji, Tonga, and Samoa in the first place. Theory 4. Refined dating just moved the goalposts. It's also worth knowing that some of what used to look like an enormous, mysterious 1,000-year-plus gap has actually shrunk in recent decades as archaeological dating techniques have improved. Older radiocarbon dates from the 20th century, some of which contributed to earlier estimates of a very long pause, have in some cases been revised as researchers developed better methods for correcting known sources of error in radiocarbon dating specific to Pacific contexts, including contamination from old carbon in marine shells and driftwood that can make sites look older than they actually are. Some newer analyses put the gap closer to 500 to 700 years rather than a full 1,000 or more. That's still an enormous stretch of time, and it's still genuinely puzzling. But it's a meaningfully different puzzle than the one earlier researchers thought they were solving, and it's a good reminder that this entire field of study is still actively moving, with real researchers actively revising real conclusions as better evidence comes in. This isn't settled history sitting quietly in a textbook. It's an active argument happening right now among people who have spent their careers on it. So which theory is correct? Honestly, probably some combination of all of them, in proportions nobody can currently prove. Shifting winds that opened favorable windows. A society steadily building the population and expertise required for the truly long crossings ahead. Ongoing exploratory voyages that left too little archaeological trace for us to find with confidence, and a dating record that's still being refined and adjusted as we speak. What we do know for certain is what happened next, because at some point, whatever combination of factors was holding things back gave way, and Polynesian voyagers pushed east again, this time reaching into some of the most remote habitable land anywhere on the planet. Into the deep Pacific somewhere around 1000 to 1200 CE, depending on which archaeological chronology you're working from, and this is another spot where the dating has shifted meaningfully over the past couple decades. Voyagers from the Samoa and Tonga region pushed east once more, and this time they didn't stop at the next convenient island. They kept going past everything anyone had previously settled, into open water that stretched for well over 1,000 miles with nothing in it at all. What they found eventually was the Marquesas Islands. If you've never looked at a map of the Marquesas, picture this. A small cluster of volcanic islands, jagged and steep, sitting almost dead center in the Pacific, roughly 3,700 miles from the coast of South America and nearly 2,500 miles from Hawaii. They are, by most measures, among the most isolated inhabited islands on Earth. The nearest inhabited neighbor of any kind is hundreds of miles away. You reach these islands, for the first time in human history, after weeks at sea, sailing on a bearing your navigator has calculated using stars, swells, and a mental model of the ocean that has never once been tested against these specific waters, because nobody has ever been here before. There is no elder who has made this crossing and can tell you what to expect on the other end. There is no story about what the Marquesas looks like from the water, because there is no story about the Marquesas at all yet. You are about to become the story, and then land. Cliffs rising almost straight out of the water in some places, deep green valleys cutting back into volcanic peaks. No coral reef ring the way many Pacific islands have, because the Marquesas are geologically young and steep enough that reefs haven't had time to build up around them the way they have elsewhere. It's a dramatic, beautiful, and genuinely difficult landscape to farm, with limited flat land and a coastline that offers fewer safe harbors than many of the islands these voyagers had known back home. They settled it anyway, and the Marquesas, it turns out, became something crucial to the rest of this story, a springboard. A growing body of linguistic and archaeological evidence points to the Marquesas as one of the key launching points for the settlement of the rest of eastern Polynesia, including, eventually, some of the most famous and most remote islands in the entire Pacific. Around the same general era, voyagers also reached the Society Islands, the island group that includes Tahiti, and which would go on to become one of the most culturally and politically significant regions in all of Polynesia. Tahiti, with its larger landmass, fertile volcanic soil, and substantial lagoon systems, developed into a major population center and, in later centuries, a genuine hub of voyaging activity in its own right, launching expeditions outward in multiple directions. This is worth sitting with for a second, because it changes the shape of the story a little. It's tempting to picture Polynesian settlement as one long, single arrow moving steadily eastward across the Pacific, like a single line drawn on a map. The reality looks more like a branching tree, or maybe more accurately, like a series of hub islands, each one becoming, once it was established and its population had grown enough, a new base for further voyages outward in multiple directions. Tonga and Samoa launched voyages that reached the Marquesas and the Society Islands. Those islands, once settled and thriving, became launching points of their own for voyages heading even further outward, toward destinations that would eventually mark the three corners of what we now call the Polynesian Triangle. Because here's the scale of what was actually happening across these centuries, and it's worth just stating it plainly, without hedging, because it's genuinely one of the more remarkable facts in all of human history. From this general region of central eastern Polynesia, voyagers eventually reached and permanently settled Hawaii, more than 2,000 miles to the north. They reached and settled Rapa Nui, better known today as Easter Island, more than 2,000 miles to the east, sitting closer to South America than to any other inhabited Polynesian island. And they reached and settled New Zealand, or Aotearoa, well over 2,000 miles to the southwest, a landmass utterly unlike anything else in tropical Polynesia, cold, mountainous, and enormous by Pacific Island standards. Draw those 3 points on a map, Hawaii, Rapa Nui, and Aotearoa, and connect them, and you get a triangle covering roughly 10 million square miles of open ocean, larger than the entire land area of Russia. Every single point inside that triangle that has land on it was found and settled by the descendants of a farming culture that started on one island off the coast of Taiwan, using boats built with stone tools and a navigation system that lived entirely in memory. We're going to visit all 3 corners of that triangle, one at a time, because each one has its own story, its own specific miracle of navigation, and in at least one case, one of the most haunting historical mysteries anywhere in the Pacific. Let's start with the corner most people know the most about and understand the least. The long jump north of the 3 corners of the Polynesian Triangle, Hawaii, is probably the one you already have some picture of in your head, even if that picture is mostly built out of postcards and surf documentaries. So let's set that picture aside for a minute and talk about what it actually took to get there in the first place, because the modern image of Hawaii tends to erase just how staggering an achievement its initial settlement actually was. Hawaii sits more than 2,000 miles from the nearest other inhabited islands in central eastern Polynesia, the general region most researchers now believe the settling voyagers set out from, likely the Marquesas or the Society Islands, sometime in a window that current archaeological consensus places somewhere around 900 to 1200 CE. Though, as with a lot of this chronology, the exact dates have shifted over the decades as dating methods have improved. And there's ongoing academic debate about narrowing that window further. Here's what makes the Hawaii crossing distinct from a lot of the other Polynesian voyages beyond the raw distance. It requires crossing a significant portion of the doldrums, an equatorial band of unpredictable, often weak and shifting winds, sometimes completely dead calm for days at a stretch, that sailors across many cultures and many centuries have described with a kind of specific dread, because a boat with no wind is a boat that isn't going anywhere, burning through food and water reserves while making no progress at all. Crossing the doldrums also means crossing the equator, or coming close to it, which brings its own navigational headache, because much of the star-based navigation system we walked through earlier depends on specific stars being visible at specific points on the horizon relative to your position on Earth. Cross far enough into a different hemisphere, and some of the stars you've spent your entire life learning to navigate by start behaving differently, rising and setting at unfamiliar points, or disappearing below the horizon entirely, while new stars you may have less experience with become your primary reference instead. None of that makes the voyage impossible. It clearly wasn't impossible since it happened more than once, resulting in successful, sustained settlement and eventually ongoing voyaging contact back and forth between Hawaii and central eastern Polynesia for at least a couple of centuries after initial settlement, based on genetic, archaeological, and oral tradition evidence. But it does mean the Hawaii crossing sat near the outer edge of what the traditional navigation system could reliably handle, and it required navigators skilled enough to essentially extend their existing star knowledge into unfamiliar sky mid-voyage without the benefit of having done it before. Once you did arrive, what you found was, frankly, spectacular, and also genuinely difficult in ways that mattered a great deal for the following centuries. The Hawaiian Islands are young by geological standards, still actively being built in places by the same volcanic hotspot that created them, which means dramatically varied terrain packed into a relatively small landmass, towering volcanic peaks, dense rainforest on the windward sides of the islands, where trade winds dump enormous amounts of rain, dry, almost desert-like conditions on the leeward sides, in the rain shadow of those same peaks, black sand beaches from relatively young lava flows, white sand beaches from ancient coral, genuinely fertile volcanic soil in places, and sharp, barren lava rock in others, sometimes within a short walk of each other. Settling successfully here meant adapting the crops and farming techniques brought from tropical central Polynesia to an environment that, in places, ran cooler, drier, or simply stranger than what those crops had evolved to handle back home. Hawaiian farmers responded over the following centuries with genuine agricultural innovation, developing extensive terracing systems that used careful water management to grow this crucial staple crop even on hillside terrain, and building sophisticated fish pond systems along the coastlines, walled enclosures that used clever engineering to let small fish swim in with the tide, grow too large to swim back out through the same gaps, and essentially turn a section of ocean into a managed, sustainable aquaculture operation. Some of these fish pond systems, remarkably, are still visible and in some cases still functional today, nearly 1,000 years after they were first built, a detail that tends to surprise people who assume ancient infrastructure automatically means ruins. Hawaiian society, over the centuries following initial settlement, developed into one of the most stratified and politically complex cultures anywhere in Polynesia, organized around a strict system of chiefs called alii, and an elaborate set of sacred laws and restrictions known as kapo, governing everything from what could be eaten by whom, to how commoners were required to behave in the presence of high-ranking chiefs, to which resources belonged to whom within a given district. This wasn't a simple society scraping by. By the time European ships arrived in the late 1700s, Hawaii supported a population that some estimates place as high as several 100,000 people, organized under competing chiefdoms across the different islands, with sophisticated systems of land management, resource allocation, and warfare. All of it built on a foundation laid down by voyagers who arrived centuries earlier with nothing but what fit in their canoes. And then for a long stretch of time, roughly from somewhere around the 1300s or 1400s CE onward, based on the evidence we have, something changes. The long-distance, two-way voyaging traffic between Hawaii and the rest of central eastern Polynesia, the kind of ongoing contact that had apparently continued for a couple of centuries after Hawaii's initial settlement, appears to largely stop. This is another one of those spots in Polynesian history where the honest answer is that we don't fully know why, though there are reasonable theories, some of them familiar from the earlier pause we already discussed. Shifting climate and wind patterns making the crossing less favorable again. Growing, self-sufficient populations on both ends that simply had less pressing need to maintain such an enormously costly, resource-intensive form of long-distance contact. The gradual loss of the specific specialized deep ocean navigational knowledge required for a crossing that difficult and that long, as societies focused their attention and resources closer to home. Whatever the cause, the practical effect was that Hawaii entered a long period of relative isolation from the rest of Polynesia, developing its own distinct culture, language, religious practices, and political systems largely independently for several centuries, right up until the moment European contact arrived in 1778 in the form of Captain James Cook's ships. Cook and virtually every European explorer who followed him into the Pacific over the following decades was consistently, genuinely stunned by two things. First, by how sophisticated and organized Hawaiian and broader Polynesian society clearly was, undercutting the simplistic assumptions many Europeans of that era carried about what they expected to find. And second, and this is the detail that matters most for our purposes, by the fact that virtually identical language, remarkably similar cultural practices, and closely related religious and social structures existed across islands separated by literally thousands of miles of open ocean, from Hawaii to Tahiti to New Zealand to Easter Island. European explorers, including Cook himself, correctly recognized this as strong evidence of a shared common origin, a single ancestral culture that had, at some point, spread itself across this entire enormous stretch of ocean. What they largely failed to correctly credit, for the next century and a half at least, was how that spread had actually happened. It would take until the mid to late 20th century, and one very determined set of researchers, sailors, and a single extraordinary traditional navigator to finally settle that question for good. We'll get there. But first, we need to talk about the other two corners of the triangle, starting with the one that might be the single most astonishing feat of ocean navigation in all of recorded human history. The loneliest island on Earth if you wanted to design the single hardest possible target for a wayfinding system built on stars, swells, and birds, you would probably end up designing something close to Rapa Nui. Rapa Nui, which most people know by its European name, Easter Island, is one of the most isolated pieces of inhabited land anywhere on the planet, full stop, not just within Polynesia. It sits roughly 2,300 miles from Tahiti, the nearest significant population center to the west, and roughly 2,200 miles from the coast of Chile, the nearest continental landmass, to the east. There is no other inhabited island within 1,000 miles of it in any direction. It is a single triangular volcanic speck, 14 miles across at its widest point, sitting almost completely alone in the largest ocean on Earth. Finding it on purpose, without any prior knowledge that it existed, using only the wayfinding system we walked through a few chapters back, is one of those facts that, once you actually sit with the scale of it, borders on genuinely hard to believe. There is no chain of stepping stone islands leading toward Rapa Nui. There is no reliable current or wind pattern conveniently pointing toward it. A navigator sailing east from central Polynesia looking for it would be sailing into open ocean with essentially no margin for error, searching for a target smaller than many cities, surrounded by thousands of miles of empty water in every direction, with no second chance if they missed it, because there was nothing else out there to hit instead. Current archaeological consensus, based primarily on radiocarbon dating that has been repeatedly revised as techniques have improved, places the initial settlement of Rapa Nui somewhere around 1200 CE, notably later than earlier estimates from the 20th century that had suggested dates as early as 300 or 400 CE. That revision matters because it places Rapa Nui's settlement within a broader, tighter window of Eastern Polynesian expansion, rather than treating it as an unusually early outlier, and it fits a growing picture among researchers of a relatively compressed, intense burst of exploration and settlement across the most remote parts of the Polynesian Triangle within just a few centuries, rather than a slow, steady trickle spread out over a much longer stretch of time. However it happened, and however many failed attempts may have preceded the successful one, leaving no trace behind for us to find, a group of Polynesian voyagers eventually found Rapa Nui, landed, and settled it permanently, carrying with them the same starter kit of crops and domesticated animals that had accompanied every other successful Polynesian colonization voyage. Chickens, certain species of rat, either deliberately or as unavoidable stowaways, and plant crops including taro, sweet potato, sugarcane, and paper mulberry. That detail about the sweet potato is actually worth pausing on for a second, because it opens up one of the more fascinating side mysteries connected to this whole story. Sweet potato is native to South America, not Polynesia. Yet archaeological and genetic evidence places sweet potato in Polynesian agriculture, including on Rapa Nui, before confirmed European contact with the region. This has led many researchers to seriously consider the possibility of at least some level of contact, whether direct or indirect, between Polynesian voyagers and South American populations, potentially involving voyages either direction, well before European ships ever entered the Pacific. It's a genuinely live area of ongoing research and academic debate, and not something with a fully settled answer yet, but it's a reminder that isolated doesn't necessarily mean completely and permanently cut off from everyone, even for the most remote island in the Pacific. Now, let's talk about what Rapa Nui is actually most famous for, because it's almost impossible to say the words Easter Island without a very specific image coming to mind: the moai. Those enormous carved stone heads and torsos, standing in rows, staring inland with an expression that's been reproduced on more novelty keychains and cartoon gags than possibly any other piece of ancient monumental architecture on Earth. Here's what actually happened, stripped of the cartoon version. Over roughly the following 4 centuries after settlement, the people of Rapa Nui, who called themselves the Rapa Nui people and their island Rapa Nui, developed an extraordinarily labor-intensive religious and social tradition centered on carving enormous stone figures, nearly 1,000 of them across the island in total, out of volcanic rock, primarily from a single quarry site called Rano Raraku. These figures, some standing over 30 feet tall and weighing upward of 80 tons, represented deified ancestors and were transported, using methods still debated among researchers, though most current evidence points toward a coordinated technique involving ropes and a walking motion rather than simple dragging on rollers, from the quarry to ceremonial platforms called ahu positioned around the island's coastline, almost always facing inland toward the community, as if watching over it. Building and transporting a single moai required an enormous coordinated community effort, and building nearly 1,000 of them on an island this small over the course of several centuries represented a truly staggering allocation of a small, resource-limited population's labor, time, and, crucially, wood, since moving these statues required substantial timber for the ropes, sledges, and levering systems involved. And that brings us to the part of the Rapa Nui story that has generated the most heated academic debate of the entire Pacific voyaging narrative: what actually happened to the island's forests, and what actually happened to its population in the centuries between initial settlement and European contact in 1722. The version of this story that became widely popularized in the late 20th and early 21st centuries, most famously through the writer Jared Diamond's book, Collapse, goes something like this. Rapa Nui's original inhabitants arrived to find an island covered in dense palm forest. Over the following centuries, driven by an obsessive religious competition to build ever more and ever larger moai, the population steadily cut down that entire forest, using the wood for statue transport, canoe building, and fuel, until the island was almost completely deforested. Without trees, soil eroded. Without soil, crop yields collapsed. Without large trees, the population lost the ability to build ocean-worthy canoes, cutting off contact with the outside world and even limiting deep-sea fishing. The result in this telling was a genuine societal collapse, warfare, starvation, and a catastrophic population crash, self-inflicted, a cautionary tale about ecological overreach that Diamond explicitly framed as a warning for the modern world. It's a genuinely gripping story. It's also, according to a considerable and growing body of archaeological research over the past 2 decades, probably not entirely accurate, at least not in the tidy, self-inflicted collapse version that became so widely repeated. Researchers including archaeologists Terry Hunt and Carl Lipo have argued, based on more recent excavation and dating work, that the deforestation of Rapa Nui was real, but that the primary driver may not have been human logging at all, or at least not human logging alone. A significant body of evidence points toward the Polynesian rat, which arrived with the original settlers, either intentionally as a food source or as an unavoidable stowaway, as a major contributing factor. Rats are highly effective at eating palm seeds and preventing forest regeneration, and on an island with no native predators to keep a rat population in check, an introduced rat population can expand explosively, and the evidence suggests Rapa Nui's rat population likely did exactly that, potentially devastating the island's ability to regenerate its forest, even as some of it was also being cut for human use. More significantly, Hunt and Lipo's research pushes back hard against the idea that Rapa Nui's population catastrophically crashed before European contact at all. Their analysis suggests the Rapa Nui people, rather than descending into violent, self-destructive collapse, actually adapted successfully to their changing environment, shifting agricultural strategies, including developing a technique known as lithic mulching, using broken volcanic rock spread across fields to protect soil, retain moisture, and release minerals slowly into depleted ground, allowing continued sustainable farming even without the extensive forest cover the island once had. Under this revised interpretation, the population of Rapa Nui may have remained relatively stable, or declined only gradually and manageably, right up until European contact in 1722, when the real catastrophe arrived not from within, but from outside. European diseases the population had no prior immunity to, followed in the following century by the genuinely horrific practice of Peruvian slave raids in the 1860s, which forcibly removed a significant portion of the island's remaining population, including, devastatingly, much of the surviving group who held the specialized knowledge of the island's own unique written language, called Rongorongo, one of the very few independently invented writing systems in human history. And one that remains, to this day, almost entirely undeciphered, in significant part because so few people who could read it survived those slave raids. This revised understanding doesn't erase the reality that Rapa Nui's ecosystem underwent a severe and lasting transformation. The forest genuinely did largely disappear. That part isn't in dispute. What's in dispute is the tidy morality tale framing self-inflicted ecological suicide through unchecked religious obsession, and increasingly, the current scholarly consensus leans toward crediting the Rapa Nui people with something closer to the opposite. Remarkable, resourceful adaptation to a genuinely difficult and changing environment, sustained successfully for centuries, right up until the point where an entirely external and entirely unprecedented catastrophe, European disease and slavery, arrived and did what internal ecological pressure alone apparently had not. It matters which version of this story gets told, and it's worth sitting with why for a second. The ecological suicide version turns Rapa Nui into a cautionary fable about human recklessness, which is a genuinely useful and important thing to think about in the abstract, but it does so at the cost of turning an entire specific, real culture, with real names and real descendants who still live on the island today, into a symbol rather than a people. The more recent research doesn't deny that hard things happened on Rapa Nui. It just insists that the people who lived through those hard things were adapting, problem-solving, resourceful humans the whole way through, not a cautionary tale waiting to happen. That distinction matters. It's the same distinction, really, that runs underneath this entire episode. The difference between these people got lucky, and these people were genuinely, remarkably good at what they did, even when what they did eventually ran into limits, external shocks, and things nobody could have planned for. The Maui are still standing today, most of them anyway, staring inland, the largest and arguably strangest physical monument left behind anywhere in the entire history of Polynesian voyaging. And underneath every single one of them is the same basic fact that underlies this entire story. Someone had to get here first, in a canoe, using nothing but memory and skill, aiming at the smallest possible target in the largest possible ocean, and they made it. The last frontier, there's a strange fact sitting at the center of New Zealand's human history that tends to surprise people who haven't thought about it before. New Zealand, one of the largest landmasses in the entire Pacific, bigger than the United Kingdom, was among the very last significant pieces of habitable land on Earth to be reached and settled by humans at all, not just by Polynesians, by anyone. While people had been living in Europe, Asia, Africa, and the Americas for tens of thousands of years, and while agriculture, cities, writing, and empires had already risen and fallen across much of the rest of the inhabited world, New Zealand sat completely uninhabited by humans until, based on current archaeological consensus, somewhere around 1250 to 1300 CE. That's remarkably recent. For context, that's roughly the same era as the height of the Mongol Empire, and only a couple of centuries before Columbus reached the Americas. An entire landmass the size of a European country, teeming with unique wildlife found nowhere else on Earth, simply had no human beings on it at all, right up until Polynesian voyagers, sailing from somewhere in central eastern Polynesia, most likely the Society Islands or the Southern Cook Islands based on genetic and linguistic evidence, found it. And finding it required solving a navigational problem meaningfully different from the ones we've talked about so far. Hawaii and Rapa Nui both sit well within the tropics, meaning navigators sailing toward them, whatever other challenges the crossing presented, were at least operating within broadly familiar tropical star patterns and weather systems for most or all of the journey. New Zealand sits much further south, well outside the tropics entirely, in a climate zone that would have felt, to voyagers raised on tropical Pacific islands, genuinely strange and unfamiliar. Cooler air, different seasonal patterns, different star behavior the further south you sail, similar in concept to the star shift problem crossing into Hawaii's hemisphere, except pushed even further from everything a tropical Polynesian navigator had spent a lifetime learning to expect. What voyagers found upon arrival was, by the standards of everywhere else in Polynesia, almost a different planet. Every other significant landmass across the entire settled Pacific Triangle was tropical or subtropical, volcanic or coral-based, generally warm year-round, and largely without dramatic seasonal shifts. New Zealand offered snow-capped mountain ranges, genuine winters, cold enough that some of the tropical crops carried from home, including breadfruit and coconut, simply couldn't survive there at all. Enormous native forests filled with tree species and plant life, unlike anything in tropical Polynesia. And wildlife that had evolved for millions of years in complete isolation from any land mammal predators whatsoever, since New Zealand had split away from the ancient supercontinent of Gondwana, long before mammals had really diversified, leaving it a land governed almost entirely by birds. Which brings us to the moa. The moa were a family of enormous flightless birds, several species ranging in size, with the largest, the South Island giant moa, standing up to 12 feet tall and weighing as much as 500 pounds, making it, at the time humans first arrived, one of the largest birds that had ever existed on Earth. With no native land predators of any kind to fear for millions of years, moa had evolved with no need for flight, no particular defensive instincts, and apparently very little fear of anything approaching them on the ground. Then humans arrived, and the ecological calculation changed instantly and completely. Moa represented an almost unbelievable food resource to the newly arrived Polynesian settlers, later known as Maori, an enormous, slow, easily hunted source of meat in quantities that dwarfed anything available on the smaller tropical islands most of these voyagers, or their recent ancestors, had come from. Early Maori settlements, especially in the South Island where moa populations were most concentrated, developed substantial economies built significantly around moa hunting, with archaeological sites revealing enormous quantities of moa bone, evidence of large-scale, intensive harvesting. And within roughly a century or two of sustained human presence, an astonishingly short window of time in evolutionary or even historical terms, every single species of moa, every one, all 9 known species, was extinct. Hunted, most researchers agree, to complete extinction by a human population that, by later population estimates, may never have numbered more than a few tens of thousands of people at any point during this era, working with nothing more advanced than Stone Age hunting technology, against a bird population that had absolutely no evolved defense against a new apex predator showing up on 2 legs with spears. This is worth sitting with for a second, because it's a genuinely striking illustration of just how fast and how thoroughly human arrival can reshape an ecosystem that evolved for millions of years in isolation, even without any of the industrial-scale technology we usually associate with large-scale environmental impact today. No guns, no traps beyond simple, traditional methods, no large-scale agriculture clearing land on an industrial scale. Just determined, skilled hunters arriving in an environment where the prey had never needed to learn fear, and a couple of centuries was more than enough time to end an entire family of species that had existed for millions of years. Alongside the moa went New Zealand's largest predator, the Haast's eagle, an enormous bird of prey with a wingspan reported in some estimates at nearly 10 feet across, which had evolved specifically to hunt moa. Once its primary food source vanished, the Haast's eagle vanished not long after, becoming one of the more dramatic and rapid secondary extinctions directly tied to human arrival anywhere in the world. This period is sometimes referred to by researchers as New Zealand's moa hunter era, generally dated from initial settlement through roughly the 1400s, after which, as moa populations collapsed and eventually disappeared entirely, Maori society underwent a significant and well-documented transition, adapting toward greater reliance on cultivated crops, particularly a specially adapted, cold hardy variety of sweet potato known as kumara. Developed and cultivated with considerable ingenuity to grow successfully in a climate substantially cooler and less forgiving than anything most Polynesian crops had evolved to handle. Fishing, shellfish gathering along the extensive coastlines, and hunting smaller remaining bird species also grew in relative importance as the moa-based economy that had defined the earliest generations of settlement came to an end. Out of this adaptation emerged the broader culture that developed into what we now call Maori society, a distinct Polynesian culture that, over the following several centuries of relative isolation from the rest of Polynesia, developed its own highly distinctive language, art, architecture, social and political structures organized around kinship groups called iwi and hapu, and an extraordinarily rich oral tradition and mythology, including detailed traditional accounts, genealogies, and stories describing specific ancestral voyaging canoes, or waka, by name, many of which are still recounted today by their descendants as living, specific family history rather than distant, abstract legend. That last detail matters more than it might initially seem to. In many parts of Polynesia, including New Zealand specifically, oral tradition preserved not vague, generalized stories about ancestors who sailed here once, but specific named accounts. Named voyaging canoes, named navigators, named routes, passed down through specific family and tribal lines across literally dozens of generations, with a level of detail and consistency that early European anthropologists, arriving with assumptions about primitive, oral cultures being unreliable or prone to distortion, were frequently and genuinely astonished by once they took the time to actually document it properly. This oral tradition, alongside archaeology, linguistics, and later genetics, forms one of the central pillars of evidence establishing the true, intentional nature of Polynesian voyaging, a topic we're about to spend real time on because it connects directly to the deliberate, decades-long campaign of dismissal that this whole achievement had to survive before finally getting the recognition it deserves. New Zealand also gave rise to one of the most visually striking and technically sophisticated pieces of Polynesian voyaging technology anywhere in the Pacific, the great ceremonial and ocean-going waka toa, enormous carved war canoes, some over 100 feet long, elaborately carved with intricate traditional designs along the hull and prow, capable of carrying upward of 100 paddlers. While these particular vessels were generally built for shorter-range warfare, ceremony, and coastal travel, rather than the deep ocean voyaging that had originally brought Maori ancestors across thousands of miles of open Pacific, they represent a direct technological and artistic descendant of the exact same voyaging canoe tradition that had carried people across the entire triangle. We've been tracing this whole episode, adapted, refined, and made distinctly local to this new, cold, enormous, and utterly unique island at the very edge of the Polynesian world. With New Zealand settled, the three furthest corners of the Polynesian Triangle, Hawaii to the north, Rapa Nui to the east, Aotearoa to the southwest, were now all reached, all permanently inhabited, all developing their own rich, distinct cultures descended from the same common ancestral root. The greatest era of Polynesian long-distance voyaging, in terms of sheer new territory being discovered and settled, was, for all practical purposes, complete. And then, over the following centuries, something happened that very nearly erased the memory of how any of it had actually been accomplished in the first place. When the canoes stopped, let's go back to that claim from the very beginning of this episode, the one about historians spending most of the 20th century insisting that all of this happened by accident. Because now that we've walked through the actual scale of what was accomplished, it's worth understanding exactly how that dismissal took hold, how long it lasted, and what it actually cost. By the time significant, sustained European contact with the Pacific arrived in earnest, largely through the 18th century voyages of explorers like Samuel Wallis, Louis Antoine de Bougainville, and most famously James Cook, the long-distance, deep ocean voyaging tradition that had originally settled the entire Polynesian Triangle had, in most regions, been in decline for centuries already, for many of the same combination of reasons we've already discussed. Growing, increasingly self-sufficient island populations with less pressing need for costly long-range contact, shifting climate and wind patterns, and a gradual concentration of the most advanced navigational knowledge into fewer and fewer specialized practitioners as its practical necessity declined. By the 1700s, most Polynesian voyaging that European explorers actually witnessed and documented firsthand was inter-island travel within a specific archipelago, journeys of dozens or a few hundred miles rather than the multi-thousand-mile open ocean crossings that had originally settled Hawaii, Rapa Nui, and New Zealand centuries earlier. This meant that European observers, arriving relatively late in this whole story, were seeing an already diminished version of Polynesian voyaging capability, impressive in its own right, as Cook's own admiring journal entries about canoe speed and seaworthiness make clear, but genuinely reduced compared to what the tradition had been capable of at its height several centuries earlier. That gap in what Europeans directly witnessed versus what had actually been achieved centuries earlier turned out to matter enormously, because it created just enough ambiguity for a very convenient, very wrong theory to take root. The theory, in its most influential and widely cited academic form, was put forward by a New Zealand-based writer and researcher named Andrew Sharp, whose 1956 book, Ancient Voyagers in the Pacific, argued, with real scholarly seriousness and a considerable amount of technical detail, that traditional Polynesian navigation was fundamentally incapable of reliable, intentional long-distance voyaging. Sharp's argument centered on the idea that without instruments, and given the genuine unpredictability of ocean, weather, and currents over multi-week voyages, precise, intentional navigation across truly vast distances, the kind required to deliberately find and settle places like Hawaii or Rapa Nui, simply wasn't plausible. Sharp proposed instead that the settlement of remote Polynesia had happened primarily through accidental voyages, canoes blown off course during storms, or fishing and short-range trading trips gone wrong, drifting for extended periods and occasionally, through sheer luck, washing up on previously unknown habitable islands, with survivors then establishing new settlements essentially by chance. Sharp's theory landed at a moment when it fit comfortably into a much older, much more broadly held set of colonial-era assumptions about Pacific Islander cultures generally, assumptions that had circulated in various forms among European scholars, missionaries, and administrators for well over a century by that point. That non-European, non-written cultures were, more or less by definition, incapable of the kind of precise, systematic, intellectually rigorous achievement that deliberate, targeted, multi-thousand-mile ocean navigation would represent. It was whether every individual scholar who cited Sharp's work consciously framed it this way or not, a theory that let an entire academic tradition avoid having to fully credit Pacific Islander cultures with what was, by any honest measure, one of the single greatest feats of exploration and navigational skill in all of pre-modern human history. The accidental drift theory held real, mainstream academic influence for the better part of 2 decades, cited approvingly across a range of history and anthropology texts, and it's genuinely worth sitting with how much damage that did, and for how long, to how this entire story was understood by the wider world. An achievement that should have stood alongside, and arguably above, virtually every other celebrated feat of pre-modern exploration in human history, the Vikings crossing the North Atlantic, the Silk Road's overland trade networks, Zhang He's 15th-century Chinese treasure fleets, got quietly reframed, in a huge swath of mainstream historical writing, as a slightly better organized shipwreck. The theory had a genuine, fundamental problem, though, and it's a problem that becomes obvious the moment you actually run the numbers rather than just the general logic. It's this: drift voyages, the kind Sharp's theory depended on, overwhelmingly move with prevailing winds and currents, and across huge stretches of the Pacific, as we discussed back in the chapter on the long pause, those prevailing winds and currents run predominantly east to west. Which means that a genuine, unpowered, purely accidental drift voyage would be expected, on average, to move in that same general direction, roughly westward, not eastward. But the actual pattern of Polynesian settlement runs directly opposite to that expectation across enormous stretches of its history. The push from Tonga and Samoa out to the Marquesas and Society Islands runs eastward, against the prevailing wind. The eventual settlement of Hawaii from central eastern Polynesia runs generally northward, again a course that a passive drift voyage would be extremely unlikely to achieve reliably. And Rapa Nui, sitting far to the east of everywhere else in Polynesia, is about as directly against a purely drift-based, wind-driven model as it's geometrically possible to get. A boat with no active navigation and no ability to sail effectively against or across the prevailing wind, simply drifting, would need an almost impossibly convenient stretch of highly unusual weather to end up anywhere near Rapa Nui at all, let alone repeatedly, reliably enough to establish, resupply, and sustain a genuine, permanent, thriving settlement there. Beyond the wind and current problem, there's the cargo problem, which is maybe the simplest and most devastating argument against the drift theory once you actually think it through. Every single successfully settled Polynesian island shows clear archaeological evidence of arriving with a full, deliberate colonization package, breeding populations of pigs, dogs, and chickens, viable seed stock and cuttings of taro, breadfruit, banana, sugarcane, and other crops, and crucially, populations of both men and women sufficient to found a genetically viable, sustainable new community. The canoe blown off course by a storm during an ordinary short fishing trip is not going to happen to be carrying pregnant sows, coconut seedlings, and a demographically balanced crew of survivors capable of viably founding an entire new, permanent, agriculturally self-sufficient civilization. That combination of cargo is not what an accident looks like. That combination of cargo is what deliberate, planned colonization looks like, prepared and loaded before departure by people who already knew, with real confidence, that they intended to find land and stay there. Starting in the 1960s and 1970s, a growing body of research began systematically challenging and eventually thoroughly dismantling the accidental drift theory through several converging lines of evidence, detailed computer modeling of realistic ocean currents and wind patterns across the actual historical era in question, which consistently showed how implausible purely accidental drift voyages against prevailing conditions genuinely were. Deepening archaeological work establishing clear, deliberate colonization cargo patterns across settled sites, and increasingly rigorous linguistic and genetic research establishing clean, traceable lines of deliberate, sequential migration rather than the more random, scattered pattern accidental drift settlement would be expected to produce. But the single most decisive rebuttal to the accidental drift theory didn't come from a laboratory, a computer model, or an academic journal at all. It came from the ocean itself, in the form of an actual, real modern voyage, deliberately built to prove once and for all that the traditional system actually worked, using the genuine traditional knowledge itself rather than any modern instrument, sailed by real people, across real open water, toward a real, specific, predetermined target. That story, the story of how this entire body of knowledge came within a hair's breadth of being lost forever, and how it was pulled back from the edge at nearly the last possible moment by one extraordinary individual, is where we're headed next. And it might be the most emotionally resonant chapter in this entire history, because it's the one with the clearest hero, the clearest stakes, and thankfully, the clearest happy ending. The man who saved an ocean's worth of knowledge by the middle of the 20th century, the specific, complete, unbroken tradition of deep ocean, instrument-free wayfinding, the whole intricate system of star paths, swell reading, and ETAC-style mental tracking that we spent an entire chapter unpacking earlier, had almost entirely died out across the Pacific. Not declined, died out. In most of Polynesia, including, remarkably, in Hawaii itself, the birthplace of one of the richest voyaging cultures in the entire Pacific, there was, by the 1960s and 1970s, no one left alive who held the complete, functional version of this navigational knowledge. It had been eroding for generations, as long-distance voyaging itself declined for the reasons we've already discussed, further accelerated by European colonization, missionary suppression of traditional practices that colonial authorities frequently viewed as primitive or even spiritually dangerous, and the simple, brutal math of oral transmission. If a chain of master to apprentice teaching breaks even once, even for a single generation, there's no book to go back and consult. The knowledge is just gone, the same way it would be gone if every copy of every book on a subject were simultaneously burned. There was, however, one place left in the entire Pacific where a genuinely complete, functional, actively practiced version of the old system had somehow survived, more or less intact, into the 20th century. A tiny, remote coral atoll in the Caroline Islands of Micronesia called Satawal, home to fewer than 1,000 people, so small and so isolated that its very remoteness had, in an odd twist, helped protect its traditional culture from a lot of the colonial disruption that had eroded similar knowledge elsewhere across the Pacific. And on Satawal, there was a man named Mau Piailug. Mau was born around 1932 into a family of traditional Satawalese navigators, and following a practice with deep roots in the local culture, began his own training as an infant, quite literally. Traditional accounts describe his grandfather placing him in tide pools as a baby, letting him experience the movement of the water directly against his body before he could even walk, as the earliest possible foundation for the kind of physical, intuitive swell reading skill that, as we discussed earlier, takes an entire lifetime to fully develop. By his teenage years, Mau had been formally initiated as a full navigator within the Satawalese tradition known as voyaging, having memorized the star compass, the seasonal star paths, the swell patterns of his specific home waters, and the full accumulated body of practical wayfinding knowledge his teachers and their teachers before them had carried. He was, by the time he reached adulthood, one of the very last people alive anywhere in the entire Pacific who held this complete, functional, traditional knowledge, capable of genuinely navigating open ocean voyages of hundreds of miles without any instrument at all, the same essential skill set that had once carried voyagers across the entire 10 million square mile Polynesian Triangle. Meanwhile, in Hawaii, a very different kind of movement was building. By the early 1970s, a growing cultural and political renaissance was taking shape across the Hawaiian Islands, part of a broader wave of indigenous cultural revival happening in various forms across many parts of the world during that era, with native Hawaiians increasingly working to reclaim, document, and revitalize language, traditional practices, and history that had been suppressed and eroded across nearly 2 centuries of colonization, missionary influence. The overthrow of the Hawaiian monarchy in 1893 and forced American annexation. Out of this movement came the Polynesian Voyaging Society, founded in 1973 by a small group that included artist Herb Cain, anthropologist Ben Finney, and waterman Tommy Holmes, built around one specific, genuinely audacious goal. Build an authentic, full-scale, traditional double-hulled Hawaiian voyaging canoe and sail it using only traditional navigation methods, along the exact same open ocean route their ancestors had originally used to travel between Hawaii and Tahiti, more than 2,000 miles of open Pacific, without a single modern instrument on board. The canoe they built was named Hokulea, meaning Star of Gladness in Hawaiian, the traditional name for the star Arcturus, which happens to pass directly over the latitude of Hawaii, making it a genuinely important reference star in the very tradition the voyage was attempting to prove had actually existed and actually worked. There was, however, an enormous, glaring problem sitting at the center of the entire project. By the early 1970s, there was no one left in Hawaii, and as far as the Polynesian Voyaging Society could determine, no one left anywhere in central eastern Polynesia at all, who still held the complete traditional wayfinding knowledge required to actually navigate a voyage like this using purely traditional methods. The whole point of the project was to prove the ancient system had genuinely worked. But the ancient system, in any complete, functional, teachable form, no longer existed anywhere in the entire region the project was trying to honor, which is how, eventually, word reached Mau Piailug on his tiny home atoll thousands of miles away in Micronesia that a group of Hawaiians were building a traditional voyaging canoe and needed a navigator who still held the old knowledge. Mau said yes. It's worth pausing on what that decision actually meant, because it wasn't a simple or small one. A traditional Satawelese navigational knowledge, voyaging specifically, was not something casually shared outside the specific lineage and community that held it. There were real cultural protocols, real restrictions, real questions within Mau's own community about whether it was appropriate to teach this knowledge, developed and protected for generations within a specific tradition, to outsiders, even Hawaiians, whose own ancestors had, after all, come from broadly the same original Pacific voyaging culture many centuries earlier, even if the specific living traditions had long since diverged and, in Hawaii's case, been almost entirely lost. Mau ultimately made the decision himself, against some resistance and real internal debate within his own community, that preserving and sharing this knowledge, even with outsiders, even at some real personal and cultural risk, mattered more than letting it potentially disappear entirely if he simply kept it to himself, and it eventually died with him and the small handful of others on Satawal who still held pieces of it. In 1976, Mau Piailug navigated the Hokulea from Hawaii to Tahiti, a voyage of just over 2,000 miles across open Pacific, using nothing but the traditional wayfinding methods we spent an entire chapter on earlier. The star compass, swell reading, bird behavior, cloud patterns, and the accumulated whole-body pattern recognition of a lifetime of training that had started, quite literally, in a tide pool as an infant on a tiny island most of the world had never heard of. He got it right. The Hokulea reached Tahiti on course, using purely traditional navigation, no instruments, in a voyage that was witnessed, documented, and verified by a modern research team specifically monitoring the crossing to test the historical claims once and for all. It is genuinely hard to overstate how significant this single voyage was on multiple levels simultaneously. Scientifically, it delivered about as direct and conclusive a rebuttal to Andrew Sharp's accidental drift theory as could possibly exist. An actual, real demonstration that the traditional navigation system, in the hands of someone who genuinely held the complete knowledge, could reliably, intentionally, accurately guide an open ocean voyage of well over 2,000 miles to a specific, predetermined destination. Culturally and emotionally, for Hawaii and for Pacific Islander communities across the entire region, it was something considerably larger than a successful scientific experiment. It was proof, delivered in the most visceral, undeniable way imaginable, that an achievement colonial history had spent the better part of a century quietly dismissing as accident and luck had, in fact, been genuine, deliberate, sophisticated human genius all along, and that it still remarkably existed, alive, in a living person, capable of being taught and passed forward rather than only studied as a historical curiosity in an archive. And Mau did exactly that. Over the following years, he formally began teaching Hawaiian students the complete traditional system, breaking, deliberately and consciously, from some of the stricter traditional protocols around how narrowly this knowledge was normally transmitted, specifically because he recognized how close the entire tradition had come to disappearing completely, and how urgent it was to make sure it didn't die with him or with any single remaining practitioner ever again. His most significant student was a young Hawaiian named Nainoa Thompson, who trained under Mau for years, absorbing the complete traditional system, and who, in 1980, became the first native Hawaiian in several centuries to successfully navigate the Hawaii to Tahiti route using traditional wayfinding methods, without Mau's direct assistance on board, effectively demonstrating that the knowledge had now been successfully, completely transmitted to a new generation, and specifically, crucially, transmitted back to Hawaii itself, restoring a version of the tradition to the very islands where it had originally been lost. Thompson went on to develop his own refined training system, sometimes called modern Hawaiian wayfinding, blending the core traditional principles Mau had taught him with additional accumulated knowledge and teaching methods designed to make this notoriously difficult, decades-long body of skill somewhat more systematically teachable to future generations of students, without ever compromising the fundamental instrument-free nature of the practice itself. The Polynesian Voyaging Society and Hokulea didn't stop after that first landmark, 1976 voyage. Over the following decades, Hokulea and her sister voyaging canoes went on to sail, using purely traditional navigation, to virtually every corner of the Polynesian Triangle and well beyond it. New Zealand, Rapa Nui, the Marquesas, and in an especially ambitious undertaking, an entire multi-year, worldwide voyage beginning in 2014 called the Malama Hanua Worldwide Voyage, circumnavigating the entire globe using the same traditional wayfinding principles Mau had taught, carrying an explicit message about environmental stewardship and cultural resilience to communities and audiences well beyond the Pacific itself. Mau Piailug passed away in 2010, on Satawal, having lived to see the tradition he had risked real cultural and personal capital to share fully and permanently restored, not just documented as history, but alive, actively practiced, and being taught to new students across Hawaii and beyond, carried forward now by multiple new generations of trained navigators who trace their knowledge in an unbroken line directly back to him. It's genuinely rare in the broader history of human knowledge to find a story with a rescue this clean, this dramatic, and this well-timed. An entire sophisticated body of scientific and navigational knowledge, developed and refined over roughly 3,000 years, that had been reduced by the early 1970s to surviving in complete functional form in essentially one place on the entire planet, inside the memory of a relatively small number of people on one tiny atoll, one of whom made the personal decision to share it at some real risk before it was too late, if Mau Piailug had made a different choice. If he had died a few years earlier, before that message reached him from Hawaii, if the Polynesian Voyaging Society had never gone looking in the first place, there's a real, uncomfortable chance that the complete, functional version of this entire navigational tradition, arguably one of the single most impressive intellectual achievements in the whole of pre-modern human history, would simply not exist anymore in any living, practicable form anywhere on Earth. It would be something scholars studied secondhand, through old European ship journals and fragments of oral tradition and educated archaeological guesswork, the same way we're forced to study a lot of other lost ancient technologies. Instead, because one man decided a body of knowledge belonged to more people than the ones who'd traditionally held it, it's alive today, being actively taught, actively practiced, and actively passed forward to new students, right now in this decade, on canoes still sailing the same ocean their ancestors crossed 3,000 years ago. What it was actually like out there, we've spent a lot of this episode talking about navigation systems and archaeological dating and academic theories, which is all genuinely important, but it's easy, moving through material like that, to lose track of the actual physical experience underneath all of it. So let's slow down for a chapter and put you back in the canoe, because 3 weeks at sea in a boat with no engine is a phrase that's easy to read past without really absorbing what it meant. You're on a double-hulled voyaging canoe somewhere in the middle of the Pacific, several days out from the last land anyone on board has seen. There are, let's say, 30 of you. Some are crew, working the sails, working the steering paddles in rotating shifts around the clock, because the canoe doesn't stop moving just because it's dark and everyone's tired. Some are not sailors at all in the traditional sense. They're farmers carrying the crops that are going to become the food supply of an entire future settlement if this voyage succeeds. There are children on board in some of these colonizing voyages. There are elderly relatives too, because you don't leave your grandmother behind when the whole point is to build a permanent new community, not run a scouting mission. There's livestock. Pigs in a section of the platform penned off for them, and pigs, it turns out, are not naturally enthusiastic about ocean travel, which means part of your daily reality is the smell and the noise of animals who are as seasick and unhappy about this entire situation as some of the humans are. chickens in woven cages, laying eggs that supplement the food supply along the way. Dogs, generally a little better adjusted to boat life than the pigs mostly. Space is not generous. The platform lashed between the two hulls is where everyone lives, works, sleeps, cooks, and eats for weeks, and it is not large relative to the number of bodies and animals and supplies it's carrying. There's a fire pit, carefully managed for cooking, because you don't stop eating hot food just because you're in the middle of the ocean, though managing an open flame on a moving wooden platform surrounded by water is exactly as delicate an operation as it sounds like it would be. Food is preserved and portioned carefully because nobody knows exactly how long this voyage is actually going to take. Dried fish, preserved breadfruit, fermented in some traditions into a paste that keeps considerably longer than the fresh fruit would. Coconut in multiple forms, meat and water both. One of the genuinely perfect voyaging foods because a whole coconut is essentially a sealed, self-contained package of both food and drinkable liquid that doesn't spoil the way most things do in tropical heat. Fishing along the way supplements all of this, trailing lines behind the canoe, and a good catch on a long voyage is a genuinely significant morale-boosting event, not a minor bonus. Fresh water is the tightest constraint of all, carried in gourds and, in some traditions, in sealed sections of bamboo, rationed carefully across a voyage whose total length isn't fully known in advance. Rain, when it comes, is collected eagerly, sails and mats rigged to funnel every possible drop into storage containers, because a stretch of unexpectedly dry weather on a long voyage is a genuinely dangerous problem, not an inconvenience. Now let's talk about what the actual days feel like, because sailing across the ocean sounds, from a comfortable distance, almost meditative. It generally was not. There's the heat, direct tropical sun for hours at a stretch, with minimal shade beyond whatever small shelter structure might be rigged on the platform, and salt water constantly present on skin and clothing and hair, which over weeks becomes its own particular kind of miserable, itchy, chafing discomfort that never fully goes away because there's no fresh water to spare for washing it off. There's the motion, constant. A double-hulled canoe is considerably more stable than a single hull would be. That's a real part of the design's genius, but more stable doesn't mean still. You are pitching and rolling with every swell, hour after hour, day after day, and if you've ever been meaningfully seasick even once in your life, extend that discomfort out across multiple consecutive weeks, and you start to get an honest sense of part of what this required physically from everyone on board, including the people whose whole job on this voyage wasn't sailing at all, just surviving the trip long enough to become farmers again on the other end. There's the boredom, which sounds like a strange thing to mention in the middle of a life or death ocean crossing, but it's real and it's worth naming honestly. Long stretches of a multi-week voyage are, by simple necessity, uneventful. Wind, water, the horizon unchanged for hours, chores, watching your section of sky for your assigned stars during your shift, more chores. It's not constant high drama. It's mostly quiet, repetitive, physically uncomfortable routine, punctuated by occasional real danger, which is, if you think about it, a pretty honest description of what most genuinely difficult, sustained human undertakings actually feel like from the inside, whether it's an ocean crossing 3,000 years ago or anything hard and long that any of us are doing right now. And then there's the danger, which is real, and which everyone on board understands is real, without it needing to be discussed constantly. The way you don't spend every day of an ordinary difficult undertaking narrating the risk out loud to yourself, because you'd never get anything done if you did. Storms are the obvious one. A serious Pacific storm, encountered mid-voyage, with no ability to outrun it and no harbor to shelter in, is a genuinely terrifying prospect, capable of destroying a canoe outright, or simply blowing it so far off its intended course that the navigator's entire accumulated mental model of the voyage's progress, built carefully over days or weeks using the ETAC system and star paths we discussed earlier, has to be reconstructed under pressure in the immediate aftermath. Using whatever fragmentary observations were possible during the chaos of the storm itself. Some voyages didn't survive their storms. We don't have detailed records of most of them, for the obvious reason that a canoe that's lost at sea doesn't come home to tell anyone what happened. What we have instead is the survivorship, the descendants of the voyages that made it, which is a sobering thing to sit with, because it means every successful island settlement in this entire story represents an unknown, probably significant, number of voyages that we will simply never know anything about at all, because nobody who could tell us the story lived to do it. There's also the simpler, quieter danger of simply running out. Running out of food if the voyage runs longer than the supplies were calculated for. Running out of fresh water in a stretch of unexpectedly dry weather with no rain to collect. These aren't dramatic, cinematic dangers. They're slow, grinding ones, the kind that show up gradually, in smaller and smaller rations, in growing thirst, in a crew getting weaker and less capable at exactly the point in the voyage when strength and clear thinking matter most. And underneath all of it, for the navigator specifically, there's a very particular kind of pressure that's worth sitting with on its own. Everyone else on board is trusting one person's accumulated mental model, built from decades of training, to be right, not approximately right, because there's no way to check the work. There's no second opinion available in the middle of the Pacific Ocean. If the navigator's internal picture of the canoe's position drifts from reality, there is no external system to catch that error before it becomes a genuine, potentially fatal problem. The entire crossing rests, for weeks at a stretch, on the accuracy of one person's continuously updated, entirely internal sense of where they are in the largest ocean on the planet. That's an extraordinary weight to carry, for weeks, without relief, and it's worth remembering it every time this whole story gets summarized down into a clean, tidy sentence about ancient navigation techniques. Somewhere behind every one of those sentences is an actual, specific person, exhausted, salt-crusted, responsible for every single life on board, staring at a night sky and a rolling swell, doing the math in their head over and over for the third week in a row, because everyone around them is depending on them getting it right. And then eventually, if everything held, if the storms didn't come, if the food and water lasted, if the navigator's internal map stayed true across all those featureless weeks, land, a smudge on the horizon that might at first just be a cloud and then isn't, a change in the color of the water, birds, more of them, closer together, clearly heading somewhere specific, and then unmistakably green, land, real land, rising up out of an ocean that had shown you nothing but itself for weeks. It's genuinely hard to imagine that moment fully from where we're sitting now, comfortable on solid ground, able to check our exact location on a device in our pocket at any second we want to. But try to sit with it for just a second anyway. Weeks of open water, no certainty, no way to check your progress against anything but your own trained mind. And then land exactly where you expected it to be because you did the work and the work was right. That's not luck. That's not an accident. That's about as close to pure, hard-won human mastery as anything in this entire history, and it happened over and over across 1,000 years, all across the largest ocean on Earth. The proof that didn't come from a boat Hercules' 1976 voyage was the proof that grabbed headlines, because it's dramatic, it's visual, and it happened in real time in front of witnesses. But it wasn't the only kind of proof that eventually settled this question for good. While Mau Piailug and Nainoa Thompson were out on the water, rebuilding the practice of traditional navigation, a completely different set of researchers were quietly building an equally decisive case from an entirely different direction: genetics. Modern genetic research, particularly studies examining mitochondrial DNA, which is passed down through the maternal line largely unchanged across generations, making it a genuinely useful tool for tracing deep ancestral population movements, has confirmed with a remarkable degree of precision the same basic migration story that linguists had already pieced together decades earlier through comparative vocabulary analysis, and that archaeologists had been tracing through the spread of Lapita pottery. Genetic studies of Pacific Islander populations consistently show a clear ancestral signal tracing back through the same general path we've walked through this entire episode, from Taiwan down through island Southeast Asia, out into the Bismarck Archipelago near Papua New Guinea, and from there in a coherent, traceable eastward sequence through Fiji, Tonga, and Samoa, and onward into the more remote reaches of eastern Polynesia. The genetic tree, in other words, tells essentially the same story as the pottery trail and the language tree, three completely independent lines of scientific evidence, developed by different researchers using entirely different methods, all converging on the same essential migration path and, broadly, the same general sequence of timing. That convergence matters enormously because it's a basic and powerful principle in historical and scientific research generally. When multiple independent lines of evidence, developed separately, using different methods, by different researchers with no particular reason to simply confirm each other's conclusions, all point toward the same underlying story, your confidence in that story goes up considerably. It's much harder to dismiss a conclusion as coincidence or bias when linguistics, archaeology, and genetics all happen to agree. Genetic research has also helped resolve, or at least significantly narrow, some of the specific open questions we've touched on earlier in this episode. Studies examining genetic markers in Rapa Nui populations, for instance, have found evidence supporting at least some degree of ancient contact with indigenous South American populations, predating confirmed European arrival in the region, adding further genuine weight to that sweet potato mystery we mentioned earlier and strengthening the case that Polynesian voyaging networks may have, at least occasionally, extended even further than the boundaries of the Polynesian Triangle itself, reaching toward the edge of an entirely different continent. Genetic research has also helped researchers estimate, with more confidence than oral tradition or archaeology alone can typically provide, roughly how large the founding populations of some of these remote island settlements actually were. Several studies suggest that some of the most remote islands, including Rapa Nui and Hawaii, may have been founded by strikingly small initial groups, in some estimates numbering only in the dozens of people, a detail that adds yet another layer of weight to just how deliberate and well-provisioned these voyages needed to be. A population that small has essentially no margin for error. Every single person, every breeding pair of livestock, every viable seed and cutting carried aboard, mattered enormously to whether the entire settlement would survive and successfully establish itself at all. None of this is the kind of evidence that makes for dramatic documentary footage the way a real canoe crossing real open ocean does. Nobody's filming a mitochondrial DNA sequencer with the same sense of adventure they'd bring to filming a voyaging canoe crossing open water toward Tahiti. But it's worth understanding that the case for deliberate, intentional Polynesian voyaging isn't resting on any single piece of evidence, however dramatic. It's resting on an enormous, independently converging body of proof, oral tradition specific and detailed enough that early anthropologists were startled by it, linguistic trees that map cleanly onto known geography, a pottery trail with a legible timeline, physical replica voyages successfully completed using purely traditional methods, and now genetic data that traces the same journey at the level of actual human DNA. Andrew Sharp's accidental drift theory didn't just lose one argument. By the time all of this evidence had accumulated, it had been contradicted from essentially every possible independent direction at once. The ocean as a road, there's a habit, when telling a story like this one, of focusing almost entirely on the dramatic firsts. First landing in Fiji, first landing in the Marquesas, first landing on Rapa Nui, on Hawaii, on Aotearoa. And those firsts absolutely deserve the attention we've given them. But focusing only on firsts can accidentally leave you with the impression that Pacific voyaging was mostly a series of one-way trips into the unknown, each island settled once and then left to develop in isolation. That's not the full picture, and the full picture is in its own way just as impressive. Once a region was settled, voyaging didn't stop. It changed shape, from exploration into something closer to infrastructure. Tonga, Samoa, and Fiji, the western anchor points of the whole story, maintained active, ongoing inter-island voyaging and trade networks for centuries, and in some cases for millennia, moving people, goods, and information across hundreds of miles of open water on a genuinely routine basis. not as a rare, heroic undertaking, but as something closer to what a regular shipping route or a well-used highway represents to us today. Fine mats, a significant ceremonial and economic good across parts of Polynesia, moved along these routes. So did specific stone tools made from particularly high-quality volcanic material available only on certain islands, traded outward to communities that had no local source of comparably good stone. So did food surplus, moving between islands experiencing good harvests and islands weathering a bad season, a form of long-distance mutual aid built directly into the voyaging network. So did marriages, alliances, political relationships, and news, carried by canoe from one community to the next across a genuinely interconnected regional network that, from a bird's eye view, looked considerably less like a scattering of isolated dots on a map and considerably more like a functioning, if watery, transportation system. Even after the era of long-range exploration into the far corners of the Polynesian Triangle wound down, this kind of regional, inter-island voyaging tradition remained active in many parts of the Pacific for centuries, right up through the era of European contact, and in some places well beyond it. It's part of why the isolated island framing that sometimes gets applied to Pacific cultures is genuinely misleading. Many of these communities weren't isolated at all. They were nodes in an active, ongoing network, connected by an ocean that most outside observers, arriving in large sailing ships built for entirely different conditions, initially mistook for an empty barrier rather than what it actually was to the people who'd grown up on it, a road. That reframing matters for how we think about the whole story. The ocean wasn't the obstacle Polynesian voyagers overcame once, heroically, before settling down. The ocean was the medium they operated in, continuously, the way we operate in a network of highways and airports and shipping lanes today, except built entirely around human skill and memory instead of asphalt, steel, and satellite positioning. The most impressive part of this whole story isn't really any single crossing, however dramatic. It's that an entire civilization built and sustained a working relationship with the largest, most unpredictable body of water on the planet, across thousands of miles and thousands of years, well enough that the ocean stopped being a wall and started being a neighborhood. What the ocean remembers. Let's come back for a second to where we started. You standing on a beach in the Marquesas, a canoe in front of you, nothing but water past the reef. By now you know what that moment actually contained. Not luck, not a storm that happened to blow someone in a useful direction. A navigator who had spent decades memorizing the sky. A boat builder tradition refined over 3,000 years, using nothing but stone, wood, and rope, that produced vessels European sea captains would later admit, in their own private journals, sailed circles around their own ships. The body of knowledge so specific and so deeply embedded in memory that it could guide a crew across 2,000 miles of open, featureless water, and land them within sight of a target smaller than most modern cities. And you know what almost happened to that knowledge too. How close it came, by the middle of the 20th century, to simply ending, surviving nowhere on Earth in complete, living form, except inside the memory of a relatively small number of people on one tiny atoll most of the world had never heard of. How one person's decision to teach it beyond the narrow circle it had traditionally been kept within is a meaningful part of why it's still here, still alive, still being taught right now, rather than something we can only reconstruct second-hand from old ship logs and archaeological guesswork. There's something worth sitting with in how long it took the wider world to actually believe this story. Not the settlement itself, which nobody seriously disputed happened, since the islands were, after all, undeniably inhabited by related peoples speaking related languages when European ships finally arrived. What took so long to be believed was the how. That it was deliberate, that it was skilled, sophisticated, repeatable navigation, not a string of fortunate accidents. For the better part of a century, a considerable amount of serious academic writing treated one of the greatest exploration achievements in human history as something closer to an extended shipwreck story. And it's worth being honest about why that framing held on for as long as it did. It wasn't because the evidence was genuinely ambiguous. It was because crediting it fully meant crediting a non-European, non-written culture with an achievement that, frankly, most European seafaring cultures of the same era hadn't matched, and in some cases still haven't. Believing the truth required letting go of some fairly deep assumptions about whose achievements counted as impressive and whose got explained away as luck. The proof, in the end, didn't come from an argument. It came from a canoe. It came from Mau Piailug standing on the deck of the Aotearoa in 1976, doing, in front of witnesses, in real time, exactly what generations of skeptical academics had insisted couldn't reliably be done without instruments. Sometimes the most decisive rebuttal to a bad theory isn't a better theory. It's just doing the thing the bad theory said was impossible, and doing it correctly in front of people who came specifically to check. There's a version of this story that ends there, with vindication, and that would already be a satisfying place to close. But there's one more layer worth sitting with before we do, and it has to do with what this entire body of knowledge actually represents underneath the specific historical facts. Every navigational tradition we've talked about in this episode, the star compass, the swell reading, the ETAC system, the bird and cloud observation, the whole accumulated body of pattern recognition that took 20 years to fully train into a single navigator, represents something that doesn't get made anymore in quite this particular form anywhere in the world. It's knowledge built entirely around direct, sustained, embodied human attention, not measurement, not instrumentation, attention. A navigator training in this tradition wasn't learning to read a dial or a screen. They were learning to notice, with their whole body and their whole accumulated experience, subtle differences in swell pattern, in cloud color, in the specific way certain birds fly at certain times of day, differences most of us, most of the time, would sail straight through without registering at all. That kind of knowledge is slow to build and, it turns out, genuinely fragile to lose, in a way that written knowledge generally isn't. A book can sit unread for 500 years and then get opened and understood again. A skill this deeply embodied, this dependent on direct apprenticeship and lived practice, doesn't survive that kind of gap nearly as well. It needs a living chain, person to person, generation to generation, without a broken link, or it simply stops existing in any form anyone can actually use. We got lucky in this specific case that the chain held barely in one place, long enough for someone to notice it was worth saving and to actually go get it before it was too late. It's worth wondering, honestly, how many other traditions like this one, across how many other cultures, weren't so fortunate. How many bodies of knowledge, just as sophisticated, just as hard-won, just as capable of doing something the rest of the world had quietly decided was impossible, simply ran out of living practitioners before anyone thought to ask them to teach it forward. That's not really a question with a comfortable answer. But it's the right note to end on, because it's the thing this whole story leaves behind, once you get past the impressive statistics about distance and timing and canoe design. Somewhere out there, right now, there's probably still knowledge like this, held by a small number of people in a small number of places, that the rest of the world has quietly decided doesn't need to be believed, or doesn't need to be asked about, or simply isn't likely to matter much longer anyway. The Polynesian voyaging tradition got its second chance. The canoe went out in 1976 and came back having proven, in the most direct way possible, that an entire civilization's worth of dismissal had simply been wrong. That's a genuinely rare kind of ending in history. Most lost knowledge doesn't get a comeback story. This one did, and it's still being written. Every time a new student on Hawaii or Satawal or anywhere else in the Pacific finishes another year of training, another voyage, another star path memorized, carrying forward something that very nearly didn't make it to them at all. Somewhere out on the Pacific right now, there's a good chance a voyaging canoe is moving across open water. No engine, no GPS, guided by someone who learned to read the sky and the swell the same way Mau Piailug did, the same way his teachers did, the same way it's been done for roughly 3,000 years, across an ocean that has never once needed a wall built around it, because it was always, to the people who actually understood it, a road. If you made it this far, thanks for sticking around for the whole crossing. If any part of this made you want to look up at the sky differently tonight, that's basically the entire point of telling stories like this one in the first place. We'll see you on the next one.